Hi everyone. So providing solution to WAEC 2025 mathematics questions that are speculated. Number 12a says the eighth term of an AP is 46 and the sum of the first 8 terms is 200. Find the I first term, I sum of the first 12 terms. Solution for 12ai. Tn, that is the any term of an A begin by Tn equal to A plus bracket opens n minus 1 bracket closes D. Substituting the 8th term, Tn is 46 equal to A plus n is 8 minus 1 bracket closes D, then multiply by D. So we now to have 46 equal to A plus 7D, equation 1. Then sum of A begin by Sn equal to n over 2 bracket opens 2A plus bracket opens 2n minus 1 bracket closes D. Then substituting the sum of the 8 terms is 200 equal to 8 over 2 bracket opens 2a plus bracket opens again 8 minus 1 bracket closes multiplied by D bracket closes. 200 equal to dividing 8 by 4 we'll have 8 by 2 above we'll have 4. 200 equal to 4 bracket opens 2a plus 7d. 7d is 8 minus 1 above giving you 7d. Then 200 equal to 8a plus 28d, that is equation 2. So if you expand the equation above, 4 times 2 gives us 8a and 4 times 7 gives us 28d. So bringing equation 1 and equation 2 together, we now have 46 equal to a plus 7d and then 200 equal to 8a plus 28d. Multiply equation 1 by 8 with the coefficient of a in equation 2. Multiply equation 2 by 1. We now have 36 equal to 8a plus 5d. Then 200 equal to 8a plus 28d. So equation 1 minus equation 2, 368 minus 200 gives us 168. 8a minus 8a gives you 0. Then 56 minus 28 gives you 28d. Make d the subject, d becomes 168 over 28, that gives you 6d. Then from equation 1, make a the subject of the formula. A becomes 46 minus 7d. Then substitute d, which is 6. A now becomes 46 minus 7 into 6. So 46 minus 7 times 6 is 42. 46 minus 42 giving you 4. So our A is 4, our D is 6. Number 2, we are asked to find, look at 12aii. Question 12aii says, find the sum of the first 12 terms. 12aii, to find the sum of the first 12 terms, we apply the formula Sn, sum of any terms, equal to n over 2 bracket 2a plus n minus 1 bracket d. We'll now substitute sum of the 12 terms, S12 equal to 12 over 2, where n is 12, 2 over 2 bracket 2 into 4. That 4 is the first term, that is 2a plus 12 minus 1 in bracket multiplied by 6. That 6 is the common difference. So we open the bracket. If we solve out, we have S12 equal to 6. 12 over 2 is 6 into 2 times 4 is 8 minus. We'll have 12 minus 1 is 11. 11 times 6, that gives us 66. So in bracket, you have 8 plus 66. So solving, 8 plus 6 gives us 74. 6 times 4 gives us 444. So that is the sum of the first 12 terms. We'll now go to 12b. 12b says the points S 70 degrees south, 60 degrees east, and Y 7 degrees south, 6 degrees east lie on the surface of the earth. I illustrate this information in a diagram. Then I find the distance between S and Y along the meridian. Take pi at 22 over 7 and the radius of the earth at 6,400 kilometers. So for 12b, which involve the diagram, won't have time for that. You can learn that from a mathematics textbook. Go to 12bii with the calculation. The angular difference theta is 70 minus 7, which is 63 degrees. So the distance between S and Y is d, given at the formula theta over 360 times 2 pi r. We substitute our theta is 63, we now have 63 over 360 times 2 times 2 over 7 times 6,400. To simplify, we have d equal to 11 times 640, that gives us 7040 kilometers. We go to question 30, which is on statistics. The question says the following are the marks scored by 20 students in a test: 15, 11, 17, 25, 13, 15, 16, 22, 24, 27. Then the second row, 20, 22, 15, 16, 15, 19, 22, 24, 22, and then 12. The first question says prepare a frequency table for the distribution using class intervals 10 to 12, 13 to 15, 16 to 18. B says calculate variance of the distribution. And C, if the pass mark for the test is 16, find the probability that a student selected at random from the class failed. So go to the calculation. So we have 13A with the frequency table, the columns, class interval, S with the mid value, F frequency, S of L, which is the S times F. Then we have the deviation, the absolute value of the deviation, which is going to obtain by using S minus mean absolute value. They will have square of the absolute value. They will have FD squared. So the first row, the class interval 10 to 12, the mean value is 11. Obtain the mean value by adding 10 to 12 and divide by 2. 10 plus 10 is 22, divided by 2, you have 11. Frequency is 2. S of F, that is 2 times 11, 22. Then the deviation for the mean is 7.65. The division square is 58.52. Then FD squared is 117.04. Second row, 13 to 15 interval. Then the mean is, the class mid value is 14. That is 13 plus 15 over 2. The frequency is 5. The S of F, 14 times 50 is 70. Then the deviation for the mean is 4.65. Then the D square, division square, 21.62. Then FD square is 108.1. Then the third one, 16 to 18. Then the S value is 17. Frequency is 3. SF 51. Then deviation for the mean is 1.65. Division squared 2.72. And then FD squared 8.16. Then going to 19 to 21, the S value is 20, F is 2, SF 40, division from the mean 1.35, division squared 1.82, then F times D squared 3.64. The 22, 24 class interval, the S value is 23, frequency is 6, S of F 138, the deviation for the mean 4.35, then D squared 18.92, then FD squared 113.52. Then 25 to 27 we have S value as 26, F2, then S of F 52, division for the mean 7.35, division squared 54.02, and then FD squared 108.04. The sum of FD squared gives us 458.5. Sum of SF gives us 373. The sum of frequency gives us 20, showing that we have 20 students. Then going to 13B, we first find the mean. Mean is given by summation of S of F all over summation of F. Summation of S of F is 373. All over summation of F is 20. You divide, have your mean, 18.65 to 2 decimal places. Then variance is summation of FD squared all over summation of F. So summation of FD squared is 458.5. And then summation of frequency is 20. Divide, have 22.93 to 2 decimal places. Number 13 says, if the pass mark is 16, probability of the student that failed. Total frequency is 2 plus 5 plus 3 plus 2 plus 6 plus 2. That is 20 already in the table. Then frequency of failure is 2 plus 5 plus 2 plus 5. That gives you 7. Probability of failure is number who failed all over total number, which is 7 over 20 as our answer. Move over to number 9. Number 9 says, Mrs. Otto spends 1 over 9 or 1/9 of her monthly salary on rent, half on food, 1/4 on clothes, and still had $195 left. How much does she earn in a month? So this is number 9A. So solution to number 9A, let Mrs. Otto's salary be equal to S. Rent, 1 over 9 of S, that gives us S over 9. Food is spent half of the salary S, that gives us S over 2. Then clothes she spent 1/4 of the salary S, which is S over 4. The remaining salary is $195. Total fraction spent is S over 9 plus S over 2 plus s over 4, that gives us 31 over 36s. Then s minus 31 over 36s gives us 195. Then 55 over 36s gives us 195, making s the subject with the standard array. S becomes 36 times 195 over 5. And that gives us 1404, $1,404. Go to the 9B. 9B says a set of a circle of radius 6 cm sustains an angle of 105 degree at the center. Calculate the I perimeter, I area of the sector. Take pi as 20 over 7. So you need to sketch the diagram for the circle or for the sector. You have the diagram there, a circle. See the center, angle at the center is 105 degree. You have the radii, AC and CB, 6 cm each. Have the arc, ASB. So the first question is the perimeter of the sector. Perimeter is given by arc length or length of arc plus 2 times the radius. So arc length plus 2r. So length of arc, the arc there is ASB, given by the formula θ over 36 times 2 pi r. So that gives us substitution. We have 105 over 36 times 2 over 1 times 2 over 7 times 6 over 1. Simplifying, we have 7 over 24 times 264 over 7. That gives us 264 over 24 when simplified further. And that gives us 11 centimeters. So this is the length of the arc. So perimeter becomes length of arc, which is 11 plus 2 times the radius. Radius is 6. So 11 plus 2 times 6, that is 11 plus 12, that gives us 23 cm. This is the perimeter of the sector. 9BII says we should find the area of the sector. Area of the sector given by 2 over 360 times pi r squared. Theta is 105, the angle at the center over 360 times 22 over 7 times 6 squared. That gives us 105 over 360 times 2 over 7 times 6 squared is 36. So once simplify further, we'll have 7 over 24 times 792 over 7 equal to 792 all over 24. So because 7 cancels 7 on the other side. That will give you 33 cm squared. So this is the area of the sector. Number 7. Yaro drove from a town, Gaja, to Banga. After 2 hours in the journey, he observed that he had covered 80 kilometers and realized that if he continued driving at the same average speed, he would end up being late for 15 minutes. If he decided to increase the average speed by 10 km per hour, he would arrive at Banga at 6 minutes earlier. Find the distance between Gaja and Banga. Number 7. Average speed equal to distance over time. So the first average speed is 80 over km over 2 hours, giving us 40 km per hour. Then let D be total distance from Gaja to Banga in kilometer. Let capital B be scheduled time to reach Banga in hours. So from that formula, making time the sub time becomes distance over average speed. So time becomes D over 40. 40 is obtained for the equation. D over 40 is equal to T plus 0.25, equation 1. 0.25 represents 15 minutes, which again, the equation 15 minutes is 15 over 60, that is 0.25 hours. So time also equal to D over 50. If the average speed is increased by extra 10, so 10 plus 40 is 50. So D over 50 becomes T minus 0.6, which is equation 2. That is 0.26 represents the 36 minutes. That is 36 over 60, that is 0.6, equation 2. So from equation 1, we now have from equation 1, we have T, making T the subject. T equal to D over 40 minus 0.25. Substitute equation 1 into equation 2, we have D over 50 equal to bracket D over 40 minus 0.25, bracket closing minus 0.6. Multiply it through by 200 to eliminate the denominators. We now have 4D equal to 5D minus 170. Collecting like terms, 4D minus 5D equal to minus 170. Minus D is equal to minus 170. Then D is equal to 170 kilometers. That's the distance between Gaja and banger. Number 6. In a certain year, the consumption pattern of electricity changes in a turn as follows. The cost of the first 30 units was $1 per unit. The cost of the next 30 units was $7.60 per unit. The cost of each additional unit was $5. A. If Amaka used 20 units of electricity in January that year, calculate the amount paid. B. If Amaka paid $2,740 in the month of February, calculate the number of units of electricity consumed. C. Find, correct to the two decimal places, the percentage change in units of electricity consumed by Amaka in January and February. Number 6A. So 20 units is less than 30 units consumed by Amaka. So amount paid for the 20 units should be 20 times $1, which is $20. That answers question A. B. 6B. For the first 30 units, Amaka paid 30 times $1, that is $30. The next 30 units, 30 times $7.60, that gives us $228. Then the total unit now is 60, 30 plus 30. So for total of the first 16 units now becomes 30 plus 228, that gives us $258. Balance of payment becomes 2,740 minus 258, that gives us $2,482. Extra unit becomes 2482 over 5. Since it's paying $5 for extra unit, that gives us 496.4, approximately 496 units. Total units used now becomes 60 plus 496, that gives us 556 units. So now go to section, we're talking about 5 questions from section B. We now go to section A. Section A, number 1. Given that universal set where S is a member and S is greater than 1 and S is less than 20, and S, of course, is an integer. Then P is a set, is a subset of S, where S is a multiple of 3. Q is also another subset of the universal set, where S is a prime number. So you can see there, where P and Q are defined as subsets of the universal set. Find A. P intersection Q prime. P intersection Q prime. For number 1, we'll first list the elements of universal set. Universal set that have the symbol that looks like U or mu. So look at the coiled bracket for set. So look at the bracket we use. So that should be right thing. So the value of S is an integer, which is higher than 1 but less than 20. The elements of S in the U symbol is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, up to 19. Stop at 19. So that dotted line means the number continues up to 19 consecutively. Then P, the elements in set P are multiples of 3. So that from 2 to 19, that is 3, 6, 9, 12, 15, and 18. The elements in Q are the prime numbers. So between 2 and 19, which include 2, 3, 5, 7, 11, 13, 17, and 19. So we're looking for P intersection Q prime. Find Q prime first. The Q prime are the elements in Q that are not in the universal set. And then they have Q prime. The elements there are 4, 6, 8, 9, 10, 11. 4, 6, 8, 9, 10, 12, 14, 15, 16, and 18. Then our P, of course, is 3, 6, 9, 12, 15, and 18. Separate each element with a comma. Then P intersection Q prime. Okay. P intersection Q prime, which the elements that are common to P, set P and set Q prime are 6, 9, 15, and 18. So that answers that question 1. 6, 9, 15, and 18 is P intersection Q prime. Question B says find P prime union Q. P prime union Q. Question B, we'll first find out P prime, which elements in set P that are not the universal set. So the P prime elements there are 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Our Q, the elements in Q are 2, 3, 5, 7, 11, 13, 17, and 19. So P prime union Q means combine elements in P prime and Q without repeating any of them. We'll have 2, 3, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. So P prime union Q are the elements listed there. Question C say find P union Q or in bracket prime. P union Q is 2, 3, 5, 6, 7, 9, 11, 12, 13, 15, 17, 18, 19. Then P union Q prime gives us 4, 8, 10, 14, and 16. Number 2 says the product of the ages of Adu and Tanko is 9 less than Akofa's age. If Tanko is 4 years older than Audu and Akofa's age is 6 times Tanko's age, find Akofa's age. Number 2. Let S be Audu's age. S plus 4 will now become Tanko's age. A, Akofa's age. So S into S plus 4 give us A minus 9, equation 1. A becomes equal to 6, bracket S plus 4, bracket closes, becomes equation 2. Substitute equation 2 into equation 1. We now have S into S plus 4 equal to 6 into S plus 4 minus 9. Expand the bracket, we have S squared plus 4S equal to 6S plus 24 minus 9, which equal to 6S plus 15. S squared plus 4S equal to 6S plus 15. S squared plus 4S minus 6S minus 15 equal to 0. That is moving the terms on the right-hand side to the left-hand side. So, collecting like terms, we'll have that. Then, solving out, we'll have S squared minus 2S. 4S minus 6S gives you minus 2S. Minus 15 equal to 0. Factorizing, S minus 5 in bracket, then S plus 3 in bracket equal to 0. So S is equal to 5. We'll take the positive value. I will neglect the negative because somebody's age cannot be negative. So S is 5. Aldo's age becomes S being 5 years. Tanko's age, which is S plus 4, which is 5 plus 4, 9 years. Akofa's age, which is 6 into S plus 4. S plus 4 is 9. So Akofa's age is 6 times 9, which is 54 years, which we are asked to find. Number 3 question says, a company installs solar panels in its premises to reduce its electricity cost. The monthly savings on electricity in dollars is modeled by the equation S equal to 200 plus 50S minus 20S squared, where S is the number of months after installation. Question A says, at what time will the savings in electricity stop increasing? So for 3A, you compare the equation, the model equation S equal to 200 plus 50T minus 200 squared to the quadratic equation written above, C plus BS plus AS squared. So here C is equivalent to 200, your B is equivalent to 50, and your A is equivalent to minus 20. So from the quadratic equation, we'll have this relationship that S is equal to minus B over 2A. And of course, we have said that A is minus 20 and B is 50, as you can see it there. Then from that relationship, S equal to minus B over 2A, you substitute, S becomes minus 50 into 2 into minus 20. That becomes minus 50 over minus 40. that S will give us equal to 1.25. So S is 1.25 moles after installation. That answers question C3A. 1.25 moles after installation. 3B says find the maximum savings. Find the maximum savings. So 3B, to find the maximum savings, we still use the modern equation S equal to 200 plus 50S minus 200S squared. So substitute the value of S, which is 1.25. We now have S equal to 200 plus 50 into 1.25 minus 20 into 1.25 squared. S becomes 200 plus 2.5 minus that 1.25. That gives us 231.25. So the savings is going to be $231.25. We have number 4, which is in form of a right angle triangle TRO. The right angle is at R. Then the distance between R and O is 84 meters. So the question says the diagram shows tower TR. So the TR is the tower. And an observer at O. So OR is 84 meters. So the distance from the foot of the tower to the observer is 84 meters. And the angle of elevation of the top of the tower T from O is 57 degrees. So 57 degrees is the angle at O. So A says calculate correct to 3SF the height of the tower. The height of the tower is your TR. So the diagram that we need. So for 4A, we have the triangle TRO. Angle 57 at O with the angle of elevation. The height of the tower is at TR. And then the RO, distance from the foot of the tower to the tower is 84 meters. To solve for the height of the tower, which is our H, the H is the opposite to angle 57. And then 84 meters is the adjacent of the triangle. Combine opposite and adjacent, that gives us tan. We now have H over 84 equal to tan 57. So make head the subject. Head becomes 84 times tan 57. Tan 57 is 1.540. So that becomes 84 times 1.540. Head becomes 129.4 meters, which is 129 meters to 3SF as demanded in the question. 4B said the observer at O moved away from the tower in the same straight line until the angle of elevation at T is 49 degrees. Find correct to 2 decimal places how far the observer moved backwards. So for 4B, we'll modify the diagram now. All we'll have to do is to replace the height TR, we'll put 129 meters there, and then remove the distance RO, which was 84 meters removed. Look for a new horizontal distance, and then remove 57 degree and put 49 degree. We still apply tan, opposite 129 meters over adjacent, which is S. So 129 over S, that gives us tan 49. Making L the subject, L becomes 129 over tan 49. We're going to be 129 all over 1.15 with tan 49. That gives us 112.22 meters. Then the observer moved 112.22 meters minus 84, the former distance. That gives us 28.22 meters backward to the 2 decimal places. Number 5. The data represents scores obtained by applicants in an interview arranged in ascending order. 3S plus 2, 22, 4S minus 2, 23, 25, 5S minus 4, 29, 29, and S squared minus 7. A. Given that the range is 9, find number I, the value of S. So for number 5A, we did the values given to you: S plus 2, 22, 4S minus 2, 23, 25, 5S minus 4, 29, 29, and then S squared minus 7. So going to the A, I, range is 9. R is range, and range is highest score minus lowest score. That gives you 9. The lowest score is 3S plus 2, since the scores are arranged in ascending order. Highest score is S squared minus 7. So that becomes highest score, substituting S squared minus 7 minus lowest score, 3S plus 2, all in bracket, equal to 9, open a bracket, we now have s squared minus 7 equal to minus 3, s squared minus 7 minus 3s minus 2 equal to 9. So collecting like terms, s squared minus 3s minus 9, minus 7 minus 7 is minus 9. Then pushing the 9 on the right hand side to left hand side also becomes minus 9. So we have s squared minus 3s minus 9 equal to 0. So solving out, s squared minus 3s minus 18 equal to 0. So this is a quadratic equation. We apply the quadratic formula, s equal to minus b plus or minus square root opens b squared minus 4ac all over 2a. Substitute s equal to minus into minus 3 in bracket plus or minus bracket in square root we have minus 3 all squared minus 4 multiplying 1 in bracket, then multiplying also minus 18 in bracket, everything all over 2 into 1 or 2 times 1. So s becomes 3 plus or minus square root of 81 over 8 over 2. If you solve the things in bracket, you have 81 over 2. And that will give you 3 plus or minus root of 81 is 9. 3 plus or minus 9 over 2. We'll take the positive answer. 3 plus 9 will give you 12 over 2. That will give you 6. So s equal to 3 plus 9 over 2, which is equal to 12 over 2, which will give you 6. So s is 6, the value of s. So 5AII says, find the mean mark of the applicants. The mean mark of the applicant, the average of the marks. 5AII, in order to find the mean marks, we first of all find all the marks, one after the other, using the value of s, which is 6, obtained from the first question. So 3s plus 2, replacing s with 6, we now have 3 into 6 plus 2, that gives you 20. 4s minus 2, replacing s with 6, that becomes 4 into 6 minus 2, that is 24 minus that, giving you 22. 5s minus 2, that means 5 times 6 minus 2, that gives you 30 minus 4, that gives you 26. S squared minus 7, that becomes 6 squared minus 7, that gives you 29. The other values that are not carrying s are 22. The other scores that are not carrying s are 22, 23, 25, 29, and also under 29. Sum of all the scores, 20 plus 22 plus 22 plus 23 plus 25 plus 26 plus 29 plus 29 plus under 29. That gives you 225. Mean is the total sum over the number 225 over 9. That gives you 25. 5b says, if 4 of the applicants who obtained the highest scores were selected, determine the pass mark. So 5b, the top 4 scores are 26, 29, 29, 29, repeat, because 3 will score 29. So after selecting these 4, the pass mark should be 26, which is the lowest of the 4 scores. The pass mark is 26, which is the lowest of the 4 scores. Okay, thank you.